Welcome back, ladies and gentlemen, to our next discussion in math. We're going to be talking about the concept of probability. On the screen you see the word probability, and around it you see some examples of what probability is. If you've ever heard someone saying, oh, you have a 1 in 3 million chance of winning the lottery, or there's a 20% chance of rain today, or you have a 0.5 chance of making an A, or 3 out of 5 students are likely to pass the exam. Those are all examples of probability statements. It is making a statement about something that may or may not happen. You need to make sure you have your summary sheet out. You need to make sure you have that ready to go, as I'm going to try and move through this as quickly as possible. And then when you come to class, we'll be able to do some examples and such. So if you have your summary sheet out, the first thing that you're asked there is, what is probability? Probability is the likelihood of an event to occur. So just like when I was saying that the example there, that 20% chance of rain. 20% chance of rain means that there is a 20% out of 100%, of course, chance that it may rain today. The next thing we need to look at is, how do we write probability? Well, the most common way to write probability is to use the ratio. A ratio is a common term to you, as we've used ratios earlier in the school year. We also know that ratios can be changed into percents, and finally they can also be changed into decimals. Probabilities can be written all three ways. They can either be written as a ratio, a percent, or a decimal. Well, they're most commonly written as ratios, and when you're looking at probabilities, your ratio will look like, of course, a fraction, and your ratio, the top part of your ratio, or the numerator, is the number of favorable outcomes, and the denominator of your ratio is the number of possible outcomes. So make sure you put that on your paper, on your summary sheet, and then as we are working through these problems, refer back to that fraction setup, or that ratio setup, looking at the number of favorable outcomes over the number of possible outcomes, because probability and writing ratios for probability comes back to this basic fraction, if you will, fractional setup, ratio setup. Okay, before we go on to set some up and do some practices, though, we need to know that there are a couple of different types of probabilities. Okay, so on your paper, on your summary sheet, it asks for the two types of probability. The first type of probability is what is called theoretical. And I am a terrible speller, as you all know, so we'll hope that that is spelled correctly. It's called theoretical probability. And I'm going to start P-R-O-B because I don't want to continue to write it out. Theoretical probability is what you think will happen. What you think will happen. Okay? The other type of probability is what is called experimental probability. This is the fun probability, because in experimental probability, it is when you actually do the activity, you do an activity and collect results. You do an activity and collect results. That is actually experimental probability. So theoretical is just making a statement about probability, what you think will happen. Experimental probability, you actually do the experiment and come up with the actual results. Now, before we can actually go into theoretical and experimental probability, we have to understand that when we are talking about events of probability events, we have to be aware that there are three. And actually, that's not correct. I'm only going to teach you two types of events. So we have theoretical probability experimental probability, and we have two types of events within that we're going to look at. We're going to look at what is called independent events. I'm having a hard time writing today. And the other one is called dependent events. Independent and dependent variables. You remember those terms from science class, independent and dependent variables? Well, independent and dependent events are very much like that. In an independent event, the outcome is not affected by anything else. When you're reading word problems with probability, the phrase that gives you out that it's an independent event, you will often see the words with replacement. So if we're looking at word problems, hint, hint, and you're thinking, is it independent or is it dependent, you'll want to look for the words with replacement. Dependent events, on the other hand, is when an outcome of one event is influenced by the outcome of another event. So with dependent outcome of another event. When we're looking at terminology for dependent events, we want to look for words like without replacement. Without replacement. Okay, so I know we've gone over quite a bit in that little piece. Just a real quick review. There are two types of probability. There is theoretical probability, where it is just what you think will happen. There is experimental probability, where you actually do an activity and collect results to see what really happened. There are two types of events that we need to know about. Independent events are when the outcome is not affected by anything else. The terms that you're listening for, or the words that you're listening for if it's in word problems, is the words with replacement. If you're talking about dependent events, these are where the outcome of one event is influenced by the outcome of another event. And when you're looking at word problems with this particular, you're looking for the words without replacement. So independent is with replacement if you're listening for word clues, and dependent events are without replacement. Okay, so going on with our discussion, let's talk about example of theoretical probability and experimental probability. First, we want to look at theoretical probability. Say I have this coin, and it has a heads and a tails, of course, on this nickel, a heads and a tails. So if I'm talking theoretical probability, I might say that if I flip this coin 6 times, it lands on heads 4 of those times. So I might say my theoretical probability would be 4, the probability of a heads, because we write probability like that with a P meaning probability and what you're looking for in parentheses. So the probability of a heads would be 4 times out of 6 is a theoretical probability. That's what I think is going to happen. But if we're talking about experimental probability, then we're actually, if we're looking for the probability of a heads, and we're looking for experimental probability, then we're actually going to flip this coin 6 times and we're going to see what comes up. So if I actually did the experimental, so there's a heads, second time is a heads, third time is a tails, fourth time is a tails, fifth time is a heads, and sixth time was a tails. So in the experimental probability, what actually happened, the probability of a heads, 1, 2, 3, actually came up 3 times out of 6. So my theoretical probability, what I thought was going to happen, wasn't actually what did end up happening when I did the experimental, but it was very close. So writing that as a ratio, 3 to 6, or it could be simplified to 1 out of 2, which is a half. 0.5, of course, as the decimal, or 50% as a percent, because we can write it all three ways. On the one up here where we were doing the theoretical, 4, 6, both divide by 2, so we end up with 2/3. As a decimal would be decimal 66 repeating. As a percent would be 66.6 repeating percent. So you can write it multiple ways. But that's just a quick example of theoretical and experimental, the difference between the two. Now, the two that you need to know more involved are the events. You need to be able to identify independent and dependent events. So, let's talk first about independent events. Independent events. And these are the ones that an outcome is not affected by anything else. It's an independent event. So, for example, if I had this dice, and it's a 6-sided dice, you can see 1 through 6, it's a standard 6-sided dice, and I wanted to find the probability of rolling a 1. If I have a 6-sided dice, 1 through 6, what is the probability of rolling a 1? Well, you have one favorable outcome, because there's only one 1 on a 6-sided dice, right? And you have 6 possible outcomes. So the ratio for having an event, in an independent event, to have a probability of a 1 when rolling a 6-sided dice is 1 out of 6. And then, of course, you could change that to a decimal, and you could also change it to a percent. So now what if I said, okay, what is the probability of rolling a 3? Well, how many 3s are there on a 6-sided dice? Well, there is 1. How many possible rolls would you have? I would have a possibility of 6. You following what I'm saying? So what if I said, what is the possibility of rolling an even number? Probability of rolling an even number. Well, if I look on a dice, I know that 2 is even, 4 is even, and 6 is even. So how many numbers on the dice are even numbers? 2, 4, and 6. So that means there are 3 even numbers. And how many total numbers are on the dice? 6. So the probability of rolling an even number on a dice is 3 out of 6, which is also equal to 1/2. Or as a decimal, 0.5, as a percent, 50%. So do you see independent events? It doesn't matter what I do as far as the dice. It's an independent event because nothing else is interacting with it. Another way to look at an independent event is to, if I have this box of cubes, and we're going to pretend that I can't see in this box and neither can you, because when you're doing probability, it is all random. You do it without looking. So I will close my eyes as I do this, but looking at the box, let's see if we can have a probability of picking an orange cube. Let's figure out our probability of picking an orange cube. Now, that's all that it says. You're looking for the probability of picking an orange cube. Let me put all these so that you can see them. So if you look at these cubes, how many orange cubes are in the box? 1, 2, 3, 4, 5. There are 5 orange cubes in the box, so the favorable outcome available is 5. And how many total cubes do you have? 2, 4, 6, 8, 10, 12, 14, sorry I didn't know how many I had in here, 16, 18, and 20. So I did put 20 cubes in the box. So I have 5 chances of actually picking an orange out of 20 chances that I would pick, which of course is the same as they both divide by 5, so it would be a 1 out of 4 chance of picking an orange cube from the group, or decimal 25, or 25% chance of picking an orange cube from the box. Are you following me? This particular activity, if I said, let's go one step further. What if I ask you to find, I'm trying to get this where we can see, let me pan out a little bit, where we can see everything together. Okay, what if I ask you to find the probability of picking a red cube and then a blue cube? So now we have to look. The probability of picking a red cube. So when we look in the box, we see how many cubes there are that are red, because that's what we're trying to find the probability of. How many could I pick that would be red? Well, when you look in the box, you see that there are 2 red cubes. Okay? So 2 out of how many? Well, we just talked about the fact that we have a total of 20. Okay? So now we need to check how many blue cubes could I pick. So you're finding a probability for the red, and you're finding a probability for the blue. So there are 3 blues out of 20. Now, watch what happens, because these are not single events. They're independent events, but it's not a single event. You're looking to find 2 things. You want to pick a red, and then you want to pick a blue. Okay? To find the probability of picking a red from this tub and then a blue from this tub, you take your 2 single probabilities and you multiply them together. So you would have a 6 out of 400 chance of picking first a red cube and then a blue cube. So if you did this, if you mixed these up and you placed them here and you picked out a cube randomly and a cube randomly and you did that 400 times, 6 of those times out of the 400 you would most likely get a red and then a blue cube. Are you following? They're separate events. One doesn't play any part on the other one because you have all of your cubes there each time you pick. What happens if I say this? So this means I'm not picking this red cube and I'm not leaving it out and then picking a blue cube, am I? No. That is when you see the words without replacement. So what if I did this? What if I said I want to see what, let me take some of these cubes out of here first though. 1, 2, 3. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10. Let's work with 10 instead of 20. All right, so what if I said without replacement? What if I said, what is the probability of picking a yellow cube and then a green cube without replacement? That means this. I take my hand, I look in there, I see, oh, there's 1 yellow, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items now. So I randomly pick out a cube. Okay. Randomly picked out a cube. We don't know what I picked out, and we don't know what's left in there. So now what is the probability of picking a green? Well, you knew there was 1 green in there, but now if I don't put the original pick back in the box, how many do I now have to choose from? Well, I have a possibility of picking 1 green, but now are there 10 cubes in the box? No. Now there are only 9. So if I use without replacement, if I don't put this cube back in after I pick it out, then my chances get considerably better. 1 times 1 is 1, and 10 times 9 is 90. So now if I were to pick twice, pick a cube, here's my entire box, I pick a cube, I leave it out, I pick another cube, the possibility or the probability of getting a yellow and then a green is if I did it 90 times, I would get a yellow and a green 1 time. Are you following me? A yellow and a green 1 time. So, let's just look at another one. What if I have this set of information right here, 10 cubes, and I want to know the probability of picking a red. Just basic probability. Okay, how many reds are in there? 2. How many total cubes? 2, 4, 6, 8, 10. So the probability of picking a red cube is 1 out of 5 chance. So if I close my eyes, that's my theoretical. If I close my eyes and I actually pick it, look at that. There's 1 chance. Okay, I have to put it back because it doesn't say without replacement. So I did pick a red on the first one. We're going to try it 10 times. I'm going to close my eyes, pick again. I picked the yellow. I'm going to close my eyes, pick again. I picked the green. I'm going to close my eyes, pick again. I picked the brown. I'm going to close my eyes, pick again. I picked another brown. So if I picked 5 times, 1, 2, 3, 4, 5, is my experimental the same as my theoretical in this one? Yes, it is, because the probability of picking a red out of 10 cubes where there are 2 red cubes is 1 out of 5, or 2 out of 10, which is the same. It's a simplified fraction. That's all it is. Now, I did that without replacement. With replacement. I apologize. I put the cube back every time, so there was always a possibility of 10 cubes in there. Now, what if I said this was with replacement? Now, let's look at it again. What if I said in 5 chances, if I was trying to pick a red, in 5 chances, and I wanted to do this without replacement? Without replacement. Watch what happens. If I want to pick a red, and then, oh, I'm sorry, I need to have 2 here. A red and then a yellow. So here we go. A red and then a yellow. Ready? So what are the chances of picking a red? Well, if I look in the box, there they are. 2 chances out of how many cubes? 10. And how many chances do I have of picking a yellow? 1, but I can't put this number down here yet because watch what happens. Here's my 10. I pick out 1 cube. I picked out a brown. Okay? Now I'm going to pick out my next cube, but I'm not replacing my brown. So now I have 1 chance of picking a yellow because that's how many yellows were in the box. But now how many are left in there that I have to pick from? Yeah, not 10 anymore. Now it is 9. So I'm going to stick my hand back in the box. I'm going to pick out again, and I pick an orange. So now my combination is brown, orange. Is that red, yellow? No, it's not. Are you following what I'm saying? There is with replacement and without replacement. And we'll do some more of those when you're in class with me so we see what we mean. Here's another. Let's look at this. What if I had blue, white, white, red, and I had Y, Y, and X. And mind you, when you have spinners like this, they have to be divided equally. So we're going to pretend, if nothing else, that my spinners are divided equally. So if I'm looking for the probability of a red X, that this will land on red and this will land on X, okay? The probability of red is going to be how many? Well, there's only 1 that's red, so 1 out of 1, 2, 3, 4. Here we have looking for an X. Well, we have 2 Y's and 1 X, so we have 1 out of how many? 3. So the probability of landing on a red and an X is 1 out of every 12 tries. All right, as I said, we will come back and we will mess with that more in class with hands-on activities. The one other thing I want to show you real quickly is, what if this is my set? That's my set. And I want to know the probability of picking an orange. What's the probability of picking an orange from that set that I have there? Well, I hope you're at home saying none, because that would be the truth. None. What if I take that green away and I want to know the probability of picking a brown? Well, what's the probability? We have 4 favorables that can be picked. We have a total of 4 items to pick from. So the probability of picking brown would be 1 or 100%. Okay, that was the final thing that I wanted to finish up with. As I said, we will come back in class together and we'll do some activities with probability so that you can have a chance of trying your hand. Sorry that the video went so long tonight. I hope you enjoyed it regardless. Probability is very, very fun. If you ever go to Vegas when you get older or to Atlantic City and you're playing the cards, probability with cards are a great way to earn you some money if you can get good at it. All right, ladies and gentlemen, have a great evening, and I will see you tomorrow.